All right, guys, if after doing today's assignment and watching my videos, um, you don't feel that a mathematical induction is your favorite, I just want you to think about this as it's not your favorite yet. What I am going to do today is I am going to go over the answers. Many of you got them right, many of you got them partially right, and it was kind of difficult to write it in a comment where your mistake was. So I am going to go over question 1 and question 2, and then I will assign 3 or 4 problems for tomorrow. So make sure you do them, and come see me we usually meet at 1, and then we can do those problems together. I can go over them with you. So if you want help, or if you don't, just try by yourself. But again, this is really fun. So I want you to see, when I was solving this with some of your friends, I was messing up a little bit too, because if you write something incorrectly or make some mistake with the calculations, it's just not going to work. So make sure you are careful with this. So take a look at how this is always structured. You always check the base case first. And the base case is you take the first term, and this was 1, and then plug in 1 for n on the right hand side. Base case is true. Then you are moving on to induction hypothesis, and you are assuming that the formula holds for n is equal to k, and then replace the n with the k. This was my mistake. I wrote the 1 in the exponent right in here, and I could not make it work when I started working on this first. Then next, you are going to show that the formula holds for the next term, which is going to be described as n is equivalent to k plus 1. And what I did here is I added the next term to the left hand side, and then I replaced the k with k plus 1. And now I want to show that the left hand side is equivalent to the right hand side. And this is the left hand side. Well, I have it, I guess, right in here. I cleaned it up a little bit. And what I like about this is, again, like when we were working with identities for trigonometry, you need to remember about all the rules from algebra in order to simplify and make your one side equal to the other. In this case, the only thing we did is, because I have 2 to the power of k plus 2 to the power of k, you can write this as 2 times 2 to the power of k. And then what happens after is, using properties of exponents, this can be written as 2 to the power of k plus 1, and then this is equivalent to the right hand side. Again, if you didn't stay organized, make sure you do for the assignment today. Make sure you write the conclusion. By the principle of mathematical induction, the statement is true for all positive integers. I will post this as a PDF document so you can take a look. The next problem took a little bit more calculations, but again, still the idea is the same. I check my base case. What happens when n is equal to 1? You take the first term, and then you plug in on the right hand side n is equal to 1. And then you do the second step, which is your induction hypothesis. So you're assuming that the formula holds for n is equal to k. Take the k, plug in everywhere in place of n. And then we are going to show that the formula holds for the next term. Because if you are able to show that it holds for the next term, and k can be any term you will choose, then that means that this formula is going to hold for any natural number. So again, I want you to take a look at substitution. Some of you did this differently, and you basically worked with both left and the right hand side, which is fine. So take a look. I plugged in the next term, which is the k plus 1 on this side. So this is my original statement, and then I am adding the next term, and then on the right hand side I am replacing k with k plus 1 in every single place. All right, so take a look at the last parenthesis. It's important that k plus 1 is written in parentheses. And then I just rewrote this after I cleaned this up. So this is just my left and the right hand side. And then what I started doing is I worked with the left hand side only. I will tell you that I did a few things that didn't lead me anywhere, and that's okay. As long as you perform operations that are legal, then that's good. But sometimes you might do something that, again, is not bringing you anywhere and you have to try something else. So I want you to see what I did. I was looking at what my right hand side looks like. I saw it was in a factored form, and I saw that there was k plus 1. I did not feel like multiplying everything, and I did notice that I have addition, and k plus 1 repeats in both of the terms. So I factor the k plus 1 out, and then this is what you will have left. So notice if you take out k plus 1, you have k times 2k plus 1 for here, and then here you will have 6 and k plus 1. Then I don't know why, well, I used the distributive property, and then I thought that would be a nice way to factor. So take a look, this is not going to bring me anywhere, because what I did is I wrote exactly the same thing that I had started with. I somehow thought, oh, this is nice, 4 terms, I can group them. Well, if you do it, then again, this is the same thing. It's not bringing you anywhere. So you actually had to clean it up and then factor it using the this method, the X method, because A is not 1. 2 times 6 gives me 12. I am looking for 2 numbers that multiply to 12, add up to 7. Those 2 numbers are 4 and 3. I split the middle term, and then I was able to group it nicely, and I was able to show that my left-hand side is equal to the right-hand side. And notice how nicely I remember to write my conclusion. By principle of mathematical induction, the statement is true for all positive integers. Again, if you want to do this with me tomorrow, stop by at 1, join the meeting. I will be there. If not, just try by yourself. I have nice questions for you to work on. All right, have a great day and enjoy this. This is really fun, and it will get even more interesting.